In this video, I'm going to teach you the right way to learn unit prefixes. And a lot of us learn this the wrong way. When I was taught in a way that it wasn't necessarily incorrect, but it's not the way that people use unit prefixes in real world applications. Most of the time, you're going to learn unit prefixes with a table that looks something like this. Okay, and it's not a wrong table, but the problem is it's missing out on something very key, and that key important factor is in real life, we're not going to think like this. You can't do it that way. It's just not usually how we think of it. What we really need to do is be able to converse with people and understand people in conversation and have an intuitive sense with the magnitude and values that are being discussed. Okay, when we're doing complicated calculations with lots of unit prefixes, we're going to have computers do that. We're going to do that through another means. We're not going to do that in our heads or through conversation. Yes, we'll do it on paper for classes and things of that nature. And if your goal is just to pass a class because the instructor won't let you have a calculator or use a computer, well then, there's other ways, there's quick ways that you can try to learn to pass that class, but that's not what I'm here to talk about. I'm here to tell you how to communicate and learn how to use unit prefixes that'll actually matter so that you can actually use them in your life and understand them. Okay, so I've rewritten some of the tables that you've seen. It's very similar. You'll notice one of the differences, some people do it left to right, horizontally. I've done this vertically, and I've put actually the smaller denomination on the top. Okay, and that's really important. And here's why. So let's say we have an example. We have 1 meter go into millimeters, right? So I have my base unit, which in this case is a meter, which would be right here, and I want to go to a millimeter. You notice when I do that, I go from the base unit up. Okay, and that's really key because a lot of people get confused with this. They think, okay, I got to use this 10 to the negative third over here, so I just multiply 1 times 10 to the negative third, but that's the exact wrong thing that you want to do. What you need to do is you need to think, okay, I'm going from this unit, this base unit, and I'm going to get more, so I'm going up, increasing millimeters. Okay, you're going to have a lot more millimeters in 1 meter, meaning there's going to be a whole lot of them. So what you got to think of, when you look at 10 to the negative 3, 10 to the negative 6, 10 to the negative 9, it's better, instead of focusing on the negatives or the positives of these values, to think about it in terms of magnitude. Okay, this is between millimeters and meters are 3 orders of magnitude. Between meters and micrometers are 6 orders of magnitude. Then you need to think, okay, what direction am I going? So if I'm going from the base unit up, I'm going to increase my total number here by 3 orders of magnitude. All right, so if I go from 1 meter to 2 millimeters, I'm going to get 10 to the third, or 1,000, which is 3 orders of magnitude, millimeters, right? So that's the way you want to look at it. You want to look, okay, if I go from the base unit, I'm going in the up direction, so I'm increasing, so I'm going to get a whole bunch of them. Okay, another problem. You want to go from 1 meter to a megameter. What do you need to do? You need to go from your base unit, which is in meters. It could be anything. It could be amps. It could be whatever you want. You go from your base unit to megameters. In this case, you're going down, right? Then you look at how many orders of magnitude you're going. You're going 6 orders of magnitude down. So if you go from a meter to a megameter, you're actually going to have a very, very small amount of megameters, which would be 10 to the negative 6 megameters. The key here is, remember, this is 6 orders of magnitude down. That's how you want to think about it. You could think of 10 to the negative 6 as 1, 10 to the 6, 1 divided by 10 to the 6, okay? So it's 6 orders of magnitude smaller than it was. But what this is doing is it's changing your mind to stop thinking about it in terms of, okay, how do I set up this problem to get all the mathematical things right? Not that that's a bad exercise, but it's not how we want to think about it. We want to be able to communicate with people. So what you need to be able to do is train your mind so that when someone says, okay, I have 1,000 micrometers, okay, you can go, all right, if I wanted to go to millimeters, well, how am I going to move the orders of magnitude mentally to get there? If you can learn to think like this and train your mind to understand the concept of orders of magnitude and then understand the direction you go, it's much more conversational in the sense that when people talk to you and they say, hey, I have a milliamp of current, you will intuitively understand that, okay, if my base unit is 1 amp, and now I have a milliamp, I have 10 or 3 orders of magnitude less than than the base unit. And that gives you a much more powerful tool as you communicate with people, because you want to be able to have an understanding of the type and the values that people are talking about. If these are just numbers in a table, or you know how to plug it into Google to search for it, the answer, you're not going to have an understanding of the value that you're dealing with. So if I said, oh, I'm going to be dealing with 1 microamp of current, I'll say, okay, I feel pretty safe around that because I know that's a pretty low value. Now, if you say I'm going to be dealing with 1 gigaamp of current, now I'm a little scared because we're talking about a huge level of current. I know 1 amp of current is very dangerous, so a gigaamp is extremely dangerous. And that's what you want to develop as an engineer or any STEM-related field that you're working in. You want to have, for whatever values and units you're working with, you want to understand the magnitudes that people are talking about. So focus on understanding how the magnitudes are related to each other. You want to understand, this is really important, you want to learn from the base unit how they relate to each other, but you also, and this is almost always overlooked, you want to understand the relationship between each other unit. So if you have micro, you want to be able to know how to go from micro to milli and micro to nano. Okay, you want to be able to go from nano to micro. You want to be able to go from milli to the base unit, milli to micro. So whatever unit you have, whatever unit you're looking at, you need to understand both going from the unit, such as giga, to the base unit, and the units around it, the prefixes around it. And if you do that, you'll start to have a better intuitive sense as you talk with people and communicate with people how these units are related to each other, how these prefixes are related to each other. So you can say, okay, I have a mega ohm of resistance, or I have 1,000 kilo ohms, and you'll be able to say, oh, okay, those are the exact same value. Okay, but I can see this happening. You go to your electronics shelf and you go to, someone tells you, hey, go pull me a 1,000 kilo ohm resistor, and you go looking for it and you can't find one. Well, that's because it's labeled under 1 mega ohm. And if you don't have that ability, you're not going to want to go look up all the different permutations of the prefixes for 1,000 kilo ohms. You want to have an intuitive sense for how these values are related to each other. And that's going to help you a lot more in the STEM and engineering worlds than just trying to understand understand a table and do these long mathematical processes. You want to, in essence, be able to do a lot of this in your head. And if it's too complicated for that, it's probably going to be done by a computer or something. If it's a multi-step process, you're probably going to use some sort of algorithm to figure it out. And that's going to be much more consistent. Okay, I hope this teaches you something. I hope you liked the video. If it was educational, if you learned something, please like it. Please leave something in the comments. If I left anything out or you want an additional explanation, let me know. I'd love to help you learn this stuff and help you learn more.
Okay, after a while of working with the table written with the prefix names as well as the exponents, I recommend getting rid of that part of the table and starting to just write this part of the table, right? So in this case, you're just focusing on the prefix itself. You will hopefully have memorized the orders of magnitude between each of the prefixes by now. You're getting closer and closer to actually having this understanding in your head as opposed to something that's in a table. And your eventual goal is to get away from having to write this down at all and just being able to know this in your head, so be able to picture this in your head. So let's do an example from in this case where we want to go from 100 kilometers to megameters. Okay, so there's always two questions we need to ask ourselves. What is the difference in order of magnitude? And number two, which direction am I going, right? So if I'm going from kilometers to megameters, I know that I'm going to decrease the total number. So I'm going to decrease the orders of magnitude, and there's going to be 3 orders of magnitude difference between kilometers and megameters. So I know I'm going to reduce this final number by 3 orders of magnitude. So if I go from 1,000 kilometers to megameters, I'm only going to be left with 1 megameter. And you want to practice these over and over and over again until you can do this in your head. Okay, just a real quick review on what is the orders of magnitude and how these unit prefixes work. So let's say you have 100 milliamps of current, right? There are two things here. There's a number and there's a unit, okay? The number is telling you how much. The unit is describing of what. Now, if I want to increase this number by 3 orders of magnitude, I have two ways to do it. I can do 100 times 10 to the third. That would be increasing that value by 3 orders of magnitude. Or another way to think about that is to move the decimal place 3 positions to the right. 1, 2, 3. 1, 2, 3. Okay, both of these are doing the exact same thing. They are increasing the magnitude of the number by 3.